Hello, and welcome back to yet another retro channel. Today, I apologize, but I'm going to give you yet another Brick of Death video. Um, I know that there are tons of these videos out there and tons of information on the internet and tons of word of mouth about the Brick of Death. But apparently it hasn't been enough. I was watching another channel on YouTube, Jay's 2 Cents. And a few days ago, he put out a video where he decided to recreate his childhood gaming system and show it to his daughter. So he went out and bought on eBay a Commodore 64 power supply, 1541 disk drive, some cartridge games, and some disc games to play. And although Jay is one of the smartest guys I know, particularly when it comes to modern computer technology. I mean, this guy will show you how to build a PC, the ins and outs of installing Windows and this, that, and the other, and he's brilliant. But when he put this video together and released it, it was one of the most cringeworthy things I've seen in a long time. Three particular cringeworthy moments that stand out to me is he had bought, like I said, some cartridge games. One of those was Gorf, and before he got everything hooked up and played it, he said that he and his team thought that Gorf was golf. He thought it was a Japanese mistranslation of golf, which, if you don't mind my saying, I think was just a tiny bit racist. The second thing that I thought was really cringeworthy is that he thought that you had to shut the computer and the disk drive down to put a disk in, and then once the disk was inserted and locked in, then boot up the computer and the disk drive. Didn't know that you could just insert the disk anytime, change the disk at any time. But probably the one thing that I found cringiest, and possibly I didn't look, but I'm guessing he got all kinds of comments about this, was that he blithely went ahead and hooked up his Commodore 64 directly to the Brick of Death without so much as even testing to see if the voltage levels were right. So apparently the word isn't getting out wide enough about these horrible power supplies. So we're going to go over it again today, and I'll show you some alternatives. So you've probably all seen the Brick of Death. This is Commodore's power supply for the later model VIC-20s and the C64. These are dual voltage power supplies. They supply 5 volts DC at 7.5 watts for this version. There were different versions with different wattages. 5 volts at 7.5 watts, so that's 1.5 amps, and 9 volts AC at 6.7 VA, which is less than an amp. The problem with them is that the 5-volt line will go bad. At some point, it will go bad in this, and most of the time when those go bad, they do so by shorting and allowing the input voltage to pass directly through to the output. Not good. You'll end up with anywhere from 6 to 10 volts. Well, anywhere, actually, it has to be anywhere from 7 to 10 volts because you have to have a 2 volt difference for your regulator to work. So the regulator will only work with an input of at least 7 volts to put out 5 volts. So anywhere from 7 to 10, 11, 12 volts going directly into your 5-volt line in your Commodore computer, which will fry the ICs, as they can only handle up to, they're rated at a 5% tolerance, so they're technically rated from 4.75 to 5.25 volts. But they will take a little more. So when we talk about the C64 saver, that'll come in important. At any rate, the problem with these, Commodore, in their infinite wisdom, decided to build their power supply in the box. You've got a transformer, you've got a linear voltage regulator, and you've got some filtering. They built it in to this box, and then for whatever reason, whether it's because they didn't want people working on it, whether it's because they thought it was a better design for heat dissipation, which makes no sense whatsoever, whatever they thought, they decided to fill this once it was electronically built. They decided to fill it with an epoxy resin. This entire case is filled with an epoxy resin, so you can't get to any of the components. And most importantly, the 5-volt regulator, which dissipates power as heat. That's how it works. Any voltage over what it's trying to regulate to, current gets turned into heat. So you have to heat sink those and allow the heat to move away from them. Otherwise, the extra heat on that regulator will speed its decay, and it will eventually fail, as any chip will if it gets too hot. That failure mode on that regulator, the 7805 regulator, is typically to fail short. If it failed open, that wouldn't be that big a deal because your C64 wouldn't work because it wouldn't be getting voltage, but it wouldn't have gotten through, or the input voltage wouldn't have gotten through to the output, and your chips most likely would not have had a problem. But the typical failure mode for the 7805 is to fail short, which means, as I've said, the input voltage or part of the input voltage gets passed through to the output directly without regulation. You send 7, 10, 12 volts out out to your power plug. It goes into the 64, which has no protection on the 5-volt line. It expects all the protection to be done in advance. That 5 volts or 7 or 10 or whatever gets passed directly to the ICs, to the CPU, the PLA, the memory, the CIAs, the ROMs, everything gets that over voltage, and you'll fry it. So what do we do about it? There are many solutions. The easiest, though not the cheapest solution, is to go and buy one of the aftermarket power supplies. There are several on the market. Off the top of my head, I know of, well, Ray Carlson used to build them. I don't know if he still does or not. There was a brand called New Brick that you could buy. This is a Keylog power supply. I have one of these. It works fine. And there may be others on the market. Those, all of them, use a modern switch mode power supply in place of the linear 5-volt regulator. Much safer. It has overcurrent and overvoltage protection built in, so it'll cut itself off if it senses that the voltage is going too high. These are a safe alternative. So these, the Keylog ones, the simple ones without the display, they make some with displays that cost a little more. But this one, I think, ran me about $45 US. That's a solution. And it does work. Second solution is something called the C64 saver. The C64 saver is a small dongle that you connect between the power plug coming off your power supply and the C64's power input jack. And what it does, it provides overvoltage protection. It monitors the 5-volt line, And if it goes above, it's about 5.3 volts. If it hits about 5.3 volts, it cuts off the 5 volts. I do have a C64 saver, if I can find it. This is a C64 saver. So, as you can see, you plug the power supply into one end of your brick of death, and you plug that into your Commodore 64. It'll give you an indicator if it's good, if it's having problems, and if the voltage is bad, you get this one. I did actually have one. I was using this, and it got over voltage, and it actually blew. There's a fuse in here as well. It blew the fuse, so it did protect my machine from the over voltage that it got. So this is a good solution if you want to continue to use your existing brick of death. These you can build them yourself. You can get the PCBs and the parts and build them yourself. Obviously, you'd have to print a case, or you can buy them pre-made. I bought this one pre-made. They run, I think, anywhere from $30 to $40 pre-made. So that's a second solution. The third solution, and the one I like to use, is I build my own power supplies. Well, assemble my own power supplies. I don't build the switching power supply. I buy those, but I incorporate them into a supply that provides the 2 voltages needed. Now, there's many ways to do this. First, you can buy an external, or buy a project case and build yourself a power supply. And this is one that I built. I incorporated an IEC power jack, so I didn't have to wire the power directly in. I incorporated a fuse, which the brick of death has. But it does have a fuse, but it's usually in the potting compound. So if it blows, you can't replace it. It's kind of stupid. And I incorporated in this one a voltage amperage meter. So if you want to see this, if I plug this in and it starts up, it's going to show me that it's providing 5.17 volts. Right now 0 amps because it's not connected, but if you connect it, it'll show you the power draw, the current draw from the machine you have connected to it. It's very useful to see if you have a short in your machine, your power draws, your current draw is going to go way up. So that's a helpful diagnostic tool in seeing what might have happened if your computer dies. Now this, I assembled this in a project case that I bought off of Amazon, and in it I am using a Meanwell brand switching 5-volt power supply and a 9-volt transformer. That's all that's in here. That's one way to do it. I have to wait for the capacitors. There you go. The second thing I did, I wanted to build myself a bench power supply for the Commodores that I keep on my bench and use for all my diagnostics, testing, and repair work. So I built this. This is another project case purchased off of Amazon. Amazon, I think it was. Now, the difference is here. This case, it came with aluminum end pieces, which are fine, except that to make space for everything you're going to put into it, you'd have to cut, and I'm not great at that. So what I did is I designed 3D printed end pieces for it that had the proper holes. I put in my little version of the Commodore logo, no big deal. This power supply has the additional features of a power switch. Again, it has the IEC connector, but both the transformer in this and the Meanwell power supply that are in it will accept either 110 or 220 volts. So I built this with a switch. Not that I'm ever going to use it here in the US, but since the features were available, I went ahead and gave it a 110 220 switch. So you can use this, and another, the IEC feature of the IEC connector is that you can buy them with US plugs or European plugs or British plugs. So that being replaceable, and that switch would allow this to be used easily in either Great Britain or the US or anywhere in Europe. Again, just like with the other one, you get the voltage display. And like I said, it's just all that's in here is a Meanwell power supply, 5 volt, 3 amp Meanwell power supply. The transformer in this is actually 18 volt center tapped. So it has the dual inputs for the 110 and the 220. And then on the secondary side, it has 9 volt half or 18 volt full across power, and I'm only using 9, only using half of it. It also has a little circuit board that's basically just power distribution, so that I didn't have to run so many wires everywhere. I built a little circuit board. On the little circuit board is a fuse, so this is fused on the input. Modifications I could make to this, but I don't think are terribly necessary. I could put input filtering to filter out, attempt to filter out RFI and EMI interference. But honestly, since the Commodore power supplies don't really do that, I thought it was probably pretty much unnecessary. So I left it off in this case. So a very simple design internally. I'm not going to take it apart because it's a pain in the butt. But this is my bench power supply. Another solution that I've done, this is a 3D printed case. I found this on Thingiverse. You can find it there and print them yourself. It took about 16 hours to print this, but it's a pretty close approximation of an original power supply brick. If you look, it's not exact, but it's close. And in this, I also built just the simple design with the Meanwell power supply, 5 volts, 3 amps, and a 9 volt transformer. This one doesn't have any of the bells and whistles. No voltage display, no IEC connector, no well, it does have it is fused. There's inside there's an inline fuse holder for the input. So I did have to use a different Meanwell power supply. The ones I've used in most of my builds have been this one. It's an enclosed power supply, screw terminals for the inputs and outputs. These do have potentiometers to adjust the voltage level, so you can set exactly what you want to be coming out of this. For this power supply, for the 3D printed case, its guts are small enough that I couldn't fit. This just wouldn't fit. I could put it this way, but then you wouldn't have room for the transformer. So this didn't work, so I switched to this. This fits just fine and allows space for the transformer. This is essentially the same power supply, still 5 volts, 3 amps. It just it's in a without the enclosure and the screw terminals. It's a smaller form factor. The only the interesting thing about this is the cables here and the cable grommets come from an actual power supply, one of these. So I removed them from this and put them in this. Now, the final thing you can do is you can actually hollow out one of these and build your power supply inside it. Now to do that, I get to show you some of the workings or inner guts of the things. So here is one that's partially been opened up. When you go to open these, you can use a screwdriver to slip in between the grommet and the base plate and start to pry it loose. You'll eventually get it to come loose. And what you'll find inside is going to look like this. And here's where you see the problem. This potting compound is the problem. This is what Commodore did. That's such a mistake. I don't know what they were thinking. But you can hollow this out. There is a way to do it. But the first thing I did was, in this case, was when I opened this up, is I pulled the grommet loose and I snipped the wires so that I could reuse them in my other build. You'd want to do the same thing if you're building into this. You'd want to get the wires loose. You want to keep as much of the wire as possible, so cut as close to the potting compound as possible. This one was a little different. This cable was cut off. So what I did here is I pulled the grommet out and I pulled the grommet off. And this is the grommet that was around this cable. It obviously had an insulation around all of it, but this all went through, and this grommet was, mounted here. That's kind of what you'll see in this case. Like I said, this was cut off already, so that's why you see the extra wires here, and they're not cut all the way back to the potting compound. But you get something like this, which you can then either use in one of these cases, or it fits perfectly in the 3D printed case that I showed you as well. So you get your cables, and then you're left with the brick. And how do you get the potting compound, the massive block of epoxy out? Well, you can pull at the sides or push, and that starts to free it. And then you can slide something very thin, a butter knife, something in, and get as much of it pulled loose on all four sides as possible. And then the technique that's there's another YouTuber who has shown this, and other people have adopted it. This is not my technique. He made things, I think he called them rebricks. But other people have shown this as well. What you do is you get yourself a couple of pieces of wood. Have to be the same height. And what you do then is, using the ridges, using the ledge that the ridges form, you're going to slide the case between the two blocks of wood. Now, the guy that did the rebrick actually made a jig, so he had a box. He put wood in between so that it fit exactly. Mine's this is a little wobbly doing it this way. But what you do after you've loosened up the sides inside is you use these blocks of wood to bang it. Now you're going to want to use. I'm not going to keep doing it because this is a desk, not a good work surface for heavy heavy impact. But you keep doing that, and eventually, once you've loosened it, the block of epoxy will slide out. And what you're left with is this. This is the block of epoxy that's in those power supplies. I just don't understand Commodore. And here you can see, this is the fuse. Like I said, if that fuse blows, there's no way to replace it. So even that is a bad design. But all your you got capacitors facing down. This is a PCB. The voltage regulator is right over here. There is a metal shield inside this block of epoxy. You can see some of it here that the transformer sits on, and the voltage regulator is attached to that cage as a heat shield. But then they put epoxy around all of it so the heat can't escape. It just makes no logical sense. But this is what will come out, and you will be left with this. This is the case of an original C64 power brick of death. And you can build your new power supply in this. Now, most people build their new power supply kind of upside down. They put the transformer and the PCB in the bottom here and use usually an epoxy to hold them in place, and wire everything up. I haven't done a conversion inside one of these original cases yet. I'm going to probably try with this one. I'm going to probably try to build onto, well, maybe not. See, these things are held in place for so long that they actually bow when they come out. So if you can see that, there's a bowing there, and there's a small bowing on the sides as well. So I may not be able to mount everything to this, but I was going to try to mount to this as I did on the other power supply, and then the 3D printed power supply. I mounted everything to the base and then slid the cover over top of it. But this and the cables are all you need to throw in a 5-volt switching power supply and a 9-volt transformer. Now, the 9-volt transformers, honestly, I found them a little difficult to locate. I almost couldn't find any 9-volt transformers at all that were not center tap. Everything I found was center tap. So either 18 volts center tapped and then you only use one side of the windings, or 9-volt center tapped, that has 4.5 volts on each side of the windings. You could use that and use the entire winding. Those are a little difficult to locate. What you might look for is a 9-volt wall wart. Those are a little more common. 9-volt wall wart, and then you'd have to open up the wall wart and steal the transformer out of it. That's what Aaron Newcomb over at the Retro Hack Shack did with his. He opened up a wall wart to get his 9-volt transformer. So, but the Meanwhile power supplies, they're available readily. You can get them on Amazon. You can get them on eBay. You can get them on DigiKey, Mauser. I think I got these from Sager Electric. I'll put the links in the description below to where you can find some of these things. But you might want to shop around because you can sometimes get better prices. Just take into account that some places also have higher shipping charges. But that's how you can build your own. So those are some solutions that exist for solving the problem of the C64 power brick of death. If you want to see real quick, I can hook one of these up. Actually, let me just get this one. I'll use this one so you can see the display in action. This is my ZIF machine, which you've probably seen in an earlier video, my video of building the ZIF machine. So let's switch over here so you can see some output. And you'll notice as it begins working, we're showing the 0.78 amps that it's drawing from the 5-volt line. Obviously, it's drawing some additional from the 9-volt. You don't see that. Couldn't find the display that would show AC voltage and amperage. DC, you can find these all day. But one that shows AC, they have some, but the minimum AC voltage that it's trying to measure is usually over 80 volts, 85 volts or so. So I can't use it for a 9-volt. But anyway, so you see it's perfectly working, giving me the voltage I need and showing me. Now, if I were to be using this machine and I would start to see that voltage spike when I wasn't doing anything, additionally particularly taxing on the machine, if I were just typing along and that voltage or that amperage would spike, I would know that something was going on my board, and I'd be able to shut it down and figure out what was going on. So that's why I find that display handy. But again, you can build your power supplies without the display. Additionally, you'll find when you build a new power supply, whether it be in a 3D printed case or in one of the original cases, this is massively heavy. This, without the potting compound, just being a transformer and a little power supply in there, way lightweight. You'll like it a lot better. Anyway, that's my discussion of the power supply replacements. I'm not going to show you how to build one. I'm not going to go in that kind of detail because there are tons of videos out there that you can watch already to see that. I just wanted to talk about what the problem was with the power supply, what the options were for overcoming it. Again, build your own, buy one, get a C64 saver or build one. There are solutions that will save your precious vintage machine from a fate worse than death. So, that being said, if you enjoyed this video, please give it a like, leave a comment. If you're enjoying what I'm providing for you, please feel free to subscribe, click the notification bell, and be notified when I put out new videos. I think most of the time they will not be coming this rapid fire. I know I've put out 3 videos this week. So I apologize if you think I'm taking up too much of your time. But like I said, I watched that Jay's 2 cents video, and I hope he sees this. Jay, do something, man. Do not plug that Commodore 64 into that power brick again. You're risking all that money you spent. You said it was something like $500 you spent. You're risking most of it by using that, frankly, ridiculously dangerous power supply. So, like, subscribe, comment, and we'll see you guys next time. Have a great day. Be safe, be well, and talk to you later.